Hello everyone, my name is Jiang Chang. Today I'm gonna introduce our work on compiler testing, which is called boosting compiler testing while emulating test programs with long execution time. Compiler is the most fundamental infrastructure in software development. Ensuring the correctness of compilers is crucially important. One common compiler testing practice uses a random program generator to generate a huge number of test programs to stress test compilers. Each of the test programs will be compiled to different executables at different optimization levels, and then the outputs will be compared against each other to differentially test compilers. This is one of the most commonly used compiler testing techniques. Different optimization level, also known as DOL. However, the execution time of different test programs varies a lot. Therefore, in practice, developers often set a timeout to control the execution of test programs. If the execution exceeds the timeout, it will be terminated. Nevertheless, it's still unclear which timeout setting is more suitable for compiler testing in this context. Existing studies use different timeout settings to control the execution of test programs due to lacking sufficient investigation. Sysmith generates random C programs that statically and dynamically conform to the C99 standard. C2V detects bugs in code coverage tools by random differential testing. HiCon uses historic data to generate more diverse programs for compiler testing. YapGen produces correct roundable C or C++ and DPC++ programs. To have a better understanding of the impact of different timeout settings for compiler testing, we first conduct a preliminary investigation on the execution time distribution on 30,000 test programs generated by Sysmith. Especially, we choose GCC 4.4.0 as subject to compile these programs into executables with O0 option. Next, we run executable and collect its execution time. This figure shows the distribution of the execution time. We can observe that although 88% of test programs execute in less than 0.1 seconds, 12% of test programs take longer than 300 seconds to execute. For further investigation, we evaluate the impact of different timeout settings on detecting bugs for GCC 4.4.0 by using test programs generated by Smith. We add 0.1 seconds as the comparison settings. The testing period is 12 hours, and we employed the DOL testing technique. This figure shows the number of bugs found for GCC 4.4.0 under different timeout settings. In general, as the value of timeout increases, fewer bugs are found. We also analyze the time spent for each timeout to find the top 1, top 2, top 5, and top 10 bugs. An appropriate timeout setting can help improve the efficiency of compiler testing. In this study, we call the program corresponding to executable that requires long time for execution or even never terminating at all as a long execution time LET test program. Now I'm gonna show you the code segments generated by Sysmith. Line 3 defines a variable p with short type. Line 5 is a for loop. P gets the return value from the full function. However, the type of return value from full is defined as unsigned char, as the minimal value of unsigned char is 0. P will be always larger than or equal to 0. As a result, the loop condition will be always satisfied. This is a huge loop. It makes the program become a AIT program. Motivated by that, we propose elect, the fast technique to eliminate test programs with long execution time for compiler testing, to identify test programs for boosting compiler testing. This is an overview of elect. First, we get program P from the generator, and after being instrumented, we have the program Q. Then we feed Q to the compiler with O0 option, setting a very short running time for executable. If it is normally ended, we will get the result. If it's still running, we should dump the coverage of this running executable, and then check the coverage to find out whether Q is an AIT program. If it is, eliminated Q, otherwise we will wait for E0 to get the result. After getting the output, we can feed Q to the compiler with other options such as O1, OS, and so on. Notice that this is the rest part of DOL. In this study, all test programs were used as generated by Smith and Yapgen. Besides, we use the default option of the code generators, which allows us to obtain diverse test programs at random. We use the 2 versions of GCC compilers and 2 versions of LLVM compilers as our subject compilers. Each testing period is 12 hours. We choose DOL with timeout setting 0.01 seconds, 0.1 seconds, and 5 seconds as the baseline. The comparison approach are elect with timeout setting 0.01 seconds and 0.1 seconds. We adapt correcting commits to identify the number of detected bugs from a set of following testing programs. We mainly consider the 3 research questions. First, can elect detect more bugs than the baseline? Second, does elect spend less time in detecting the same bugs than the baseline? Third, how different timeout settings in elect affect its ability in detecting bugs. As for question 1, this is the detection result of bugs. Elect detects the most bug of. As for question 2, this table shows the time spent on detecting each bug by using Smith. Elect spent less time than the baseline in detecting some bugs. This table shows the time spent on detecting each bug by using Yapgen. Elect spent less time than the baseline in detecting more than half the number of bugs. As for question 3, elect 0.01 detects all bugs in no more time than elect 0.1. Now I'm going to talk about the effectiveness of elect. For the number of detected bugs, elect can find up to 19.18% more bugs than the baseline. For the time spent on detecting bugs, elect can save up to 37.69% more time than the baseline. In conclusion, we first conduct an empirical study to evaluate the impact of different timeout settings on the effectiveness and efficiency of compiler testing. We found that the timeout used in previous work seriously affects the efficiency of the testing process. Then, we introduced a new concept of long execution time (LET) test programs in compiler testing. Last, we proposed the first simple but effective technique named ELECT to identify LET test programs for boosting compiler testing. Our evaluation on the old versions of GCC and LLVM have demonstrated that ELECT can significantly improve the efficiency of existing compiler testing technique. If you have questions or comments, please feel free to contact me. Thank you for your listening.